we're going to be going over this first. So first is the x-intercepts. And there's 3 different ways we learned how to do the x-intercepts. What's one way? Factoring. What's another way? Well, discriminant's going to tell me how many x-intercepts, but what's the big overall equation? Quadratic formula. So that discriminant would just tell me, is there an x-intercept? And if there is, how many? And what's the third one? Starts with completing the square. Good. Completing the square. And so these are the 3 different ways that we learned how to get our x-intercepts. It doesn't matter if Taylor decides to do completing the square and Gabby decides to do factoring. No, you get the same answers. So I think the easiest for me, and we're going to go over this next class, is factoring, because you're just doing, since A is 1, you're just figuring out what multiplies to 5 and adds to -6. So what multiplies to 5 and adds to -6? -5 and -1. Ding, ding, ding. So I rate it as factors, x minus 5 and x minus 1. But your x-intercepts, remember, are the opposite, because they need to make sure to equal 0. So what can I subtract 1 from to get 0? Or how do I get x by itself? Yeah, plus 1, so it would be x equals 1. What else does x equal? 5, right? So these are your 2 x-intercepts. If you want to write it out, x minus 5 equals 0, and solve for x, you can, but you don't need to do that much work. You can just look and see, okay, what minus 5 equals 0? 5. What minus 1 equals 0? 1. And so I'm going to plot those right here. So 1 and 5, 2, 3, 4, 5. Beautiful. Those are your 2 x-intercepts. So if you use quadratic formula, remember, you can plug that right into your calculator. A lot of you guys know how to do that, and you should be getting the same answer. If you did completing a square, same thing, you should be getting the same answer. Remember, this test is timed, so I want to make sure you're able to do it the quickest way. Now, y-intercept, we always plug a certain number in for our x-coordinate. What number is that? 0, right? So, when x equals 0, that's your y-intercept. And so I'm just going to plug 0 in for x to figure out what is my y. So I'm using the original equation. What's 0 squared? 0 minus, what's 6 times 0? 0 plus 5. What do you end up getting? 5. So this 5 is your y-intercept. Also notice when we're in standard form, it's just always your constant. That's always your y-intercept. We'll be going over that today. So the y-intercept's 5, so I'm going to plot 5 right there. So this is kind of a prelude to what you're going to be doing today.
What's that number?
Yeah, so it's either the constant, or if I plug in 0 for x, you end up getting 5 anyways. The last one we're going to do is vertex. So you can either do it, we can either convert to vertex form, right? Which is like completing the square. We'll go over that today. Or you can do the equation. But you guys need to remember that equation. What was the equation?
B squared.
That's discriminant.
Negative b over 2a.
Yep, so it's the outside of your quadratic equation. So remember, b squared minus 4ac is your discriminant. That just tells you how many x-intercepts. This tells me my x-coordinate of my vertex. So what is the b? -6 over 2, and what's your a? Cool. What is the opposite of -6? And 2 times 1? What is 6 divided by 2? And so that's your x-coordinate of your vertex, right? That's what we learned last class. So I would go up to where x equals 3, and I'm going to draw a dotted line. Why? Because it's your axis of symmetry, right? 3 is your x-coordinate, your vertex. We also know it's your axis of symmetry. So it's what's slicing the parabola in half. To find your y-coordinate, what do? Plug it in, plug it in. So instead of x squared, I'm going to plug in 3. So x squared, what was it? Oh, minus 6x plus 5. So what is 3 squared? Good. 9 minus 18 plus 5. What's 9 minus 18? Negative 9 plus 5? Negative 4. So that's your y coordinate of your vertex. So I would go up here, and I would go down to negative 4, and I'm going to plot, because that's my vertex right there. We can tell already, if your A is positive, Patricia, is it going to be a smiley face or a frown? Your parabola. A smiley face, right? So we can draw and connect those dots to make it a smiley face. If it's positive, Patricia, are you going to have a min or a max? A min. And so my other class, how they remember it, which is kind of corny, they said positive Patricia can get all the men or min, but negative Nancy can't get any min. So I know it's silly, but that they came up with that. So they said positive Patricia can get all the min or men, but negative Nancy doesn't have a min. What does she have? Max. So you want to use that. Kind of corny, but it's fine. So this negative 4 would be your what? Your min or your max?
Your min.
Min. So, like right now, we're kind of combining. For the rest of this unit, it's nothing new. There shouldn't be anything new added to this unit. It's everything we've been doing. We're just kind of practicing and bringing it all together. So until your tests, every lesson after this or this lesson and on is all just kind of practice, bringing it together. Does this make sense? Which part of it? So you get the x-intercepts.
I mean, the thing, like, I feel like everything is like coming together and it's confusing me. But it's like
We're going to break it down right now. So this is like a prelude, and so yeah, this is lesson 13. There's a ton of lessons that we've learned up to this point where it's like mumble jumble in our brain. Does anyone else feel that way? Because when I learned this, I felt this way. This is a bunch of literally different ways to do the same thing. Like this is confusing, so that's why I spend a lot of time just kind of bringing it together. So until I feel like you guys got it together, which may take 1 class and may take 4 classes, I'm going to make sure you guys got it down. So, like, there's no new material yet. Like, it's it. So now we're going to make sense of it. And so that's why if this is mumble jumble, this is kind of see where we're at, and then we're going to go through and break it down. Yeah.
Okay, so is the reason why we're learning all these different ways is because on milestones, are they going to ask us to do a certain way?
Yeah. So, like, even, and if you were on the Saturday session, I know a lot of you were, like, one of the open-ended from, like, the milestone from the past said, like, show me the steps to complete the square. Like you would have to explain step by step how you would complete the square. Most of them, like you can solve every one using the quadratic formula. So getting your x-intercepts, as long as everything's on one side, you can always use the quadratic formula and it will get you the same answer. The reason is sometimes they're going to say, when is it factored form? When is it in vertex form? And that's actually what we're getting into next class. And so that's why we're learning all these different ways to do the same problem. Yeah. Okay, so I'm going to be going over the notes. So the only notes we have today is this little sheet right here. So you're folding it this way, and we're going to be taping or gluing it into your book. And so it looks something like this, where it says standard form. And if you want to use different colors, you can use different colors. I have one other pen. Taylor's using one of them. Does anyone want a color pen? Me? Or you guys can share if you want it. Or I have colored pencils. So it's that folded sheet. Yep, they're folding it. And so the outside should look like this, right? Standard form. What's the next one? Vertex form.
Yeah.
And then
Factored form.
Is factored form now? No, vertex form. And then factored. Cool. Cool. So, the front, we're just putting the original function. So on the front, these are the equations that you actually get on your milestone reference sheet. So this shouldn't be anything new. Standard form, right in that certain color, you're just writing right under where it says standard form, is y equals ax squared plus bx plus c. So that's standard form.
are we right now?
Yeah, no, right where on above standard form. Yeah, right over below, above, below. So this is the front of your sheet right here. So you're just writing the parent functions. Vertex form looks something like this. So vertex form, it looks like that, right? So where the vertex form is different color, or if you're using a pencil, you're writing vertex form. And then factor form is when it looks like factors, right? So like this. And this is how the equation will look on your sheet. So that just means in factors. So if they're asking you to get something in factored form, your answer should look like that. If it's in vertex form, it will look like the middle one, and the first one standard form. And so we're just going to be going over today, when is it best to use each one? And so after that, we're going to break up into different groups and different ways we're going to be using this. And then each group will be 15 minutes. Okay, so this should be the front of your page. Does everyone have that down? So let's flip it to the inside, right? And these are our only notes, so this is all, make sure you're paying attention. This is the only final copy today. So the next page should look like this. So it says best, or at the top of the left, what does it say?
What is it?
What is it? So when it says that, I'm just going to give you a parent function. So the function I'm going to give you is actually going to be in factored form. So it's going to look like this. X plus 10, x plus 2 equals y. So that's going to be on the bottom where it says factored form. So on the very bottom, I'm starting at the bottom where it says factored form. I'm going to give you an equation in factored form. And we're going to be working our way up to figure out how do we get it into each standard form and vertex form. So I'm going to start with factored form. So here's factored. And so in factored form, it says it's best to use if, when would it be best to have something in factored form? Already in factored form, come in. Like if some,
find the x-intercept.
Beautiful. So when we're looking for the x-intercepts, what's another word for x-intercepts? Root. So this is your last square. Solutions, one more. Zeros. Your x-intercept is when what equals what? Beautiful. Your y-coordinate equals 0. Also, when you see something as your x-intercept, it's usually when something lands or hits the ground. So when you're looking at word problems, it mentions like hits the ground, or your y equals 0, it's best to use factored form. So it should all be right here at the bottom. So make sure you write all that down. So does everyone have this down? All right, I'm going to go to the first one now, which is standard form. And so you can still see it, it's right here. So hits the ground, x-intercepts, roots, solutions. So whenever they're asking for that, it's best to use factored form. Because remember, it's always the opposite of what's in here. So what would your two x-intercepts be? Negative 10 and negative 2, right? Okay, I'm going to go up here. So this is standard form, right? And so how would I go from factors like this to standard form? We learned 3 different ways. What 3 ways did we learn to go from standard or factored to standard form? Box method. What else? Distributed and FOIL, right? So whichever way you guys want to use, you can put whichever way you use up here. So if you use FOIL up here. If you use box method, just as a little, or you can do distributive property. So whichever method you do, that's what we're going to be doing to get from the bottom one to the top one. So, how many people use distributive property? How many people use FOIL? Box method. Okay, so I'll do a box method just so you can see, but if you do distributive property, do it that way. So this is like this, where I have x plus 10 up here, x plus 2. Does it matter if I switch them and put x plus 2 at the top and x plus 10 at the bottom? No, right in there, right where you have it. Yep. No, it doesn't matter. So what's x times x?
X squared.
X squared. What's 10 times x?
10x.
10x. What's 2 times x?
2x.
And 2 times 10?
20.
20. Then we combine like terms or add them. Which ones have the same last name?
2x.
2x and 10x. So now let's rewrite it. So we have x squared, this guy. What is 10 plus 2? 12x. And what's that loner on the end? 20. So that's standard form, right? Sure. I'll put the distributive property underneath and then I'll erase it. So only do this if you're doing the distributive property. So this is when like x plus 10, remember they broke up. Boo-hoo. 4x plus 10. But x plus 2, that couple's still friends with both of them, right? So they gotta visit both of them, make sure they're alive and well, right? And then you multiply. So what's x times x? Or x a second. X times 2? 2x. 10 times x. And 10 times 2. Cool. And then you just combine like terms. So it would be x squared plus 12x plus 20. So see, you get the same answer, however you want to do it. Yep, whichever way. It doesn't matter. So that's when we're going from multiplying polynomials, going from factored to standard form. Oh, when's the best to use it? I didn't get there yet. I'm just doing that, both of them. Does everyone who's copying this down have it down? Yeah? Okay. There we go. Okay, when is it best to use it? When we were on our bell ringer, right, what did we find that we just kept it in standard form? It was, or when we were looking at our, which intercept was it best that I said, oh, you could just look at this number and get that intercept.
What?
The y-intercept, right? So it's best to use if you're looking for the y-intercept, because your y-intercept is just a constant for your c. What other words did we learn that mean y-intercept? Do you remember, like when we did word problems for linear equations and things like that? Starting, initial value, starting point. And what is our x-coordinate for our y-intercept? 0. So those are the different ways, the reason why we wouldn't need to change it around. So if they're looking for the y-intercept, it's standard. Or if they're saying, okay, if I'm throwing this to Jabari, my height, my starting height that I started by throwing the pen, right? That would be my y-intercept. So your starting or your initial value. Okay. The next one is the middle one, and it is a lot of steps. So I want to make sure you guys write small if you write large, or you can finish it off in your composition. And so the next one's vertex form. And we remember we use a certain method to go from standard to vertex form. What was that method? Completing the square, right? So that was when we did completing the square, but we stopped before we took the radical. So this is kind of bringing everything back. So completing the square is how we get from here to here. So I have x squared plus 12x plus 20 equals y. And I need to do completing the square. I'm probably going to go into this, so I'll probably have to erase that in a second. How do I start off completing the square? Beautiful. Subtract 20 on both sides. And you end up getting x squared plus 12x plus what? Blank equals negative 20 plus what? Blank. Good. And I say it weird because you need to remember completing the square is blanks. If you're all square, it looks like a blank almost. Then how do you get what goes with blanks? And you square it. So what is half of 12?
6.
6 and 6 squared? He goes right here, and since there's nothing on the outside, he also goes right here. So 36 goes in both the lines.
No, but you said since there's nothing on the outside.
Remember when we divided? Remember when x squared, there was a number next to it, and I would have to divide these both and have them on the outside, and you bounced.
Oh.
Yeah. And we'll be reviewing that in a little bit too. So let's turn this into this perfect, cute little square, and I'm going to erase this right here so I can continue. All right, so how do I get it into a, there we go, perfect little square? What multiplies to 36 and adds to 12? 6 and 6, right? And since that's a plus sign, what goes right here? Still the same. So if this is a plus sign, that's a plus sign. Because I'm adding to positive 12. If this was negative, it would be, I'm going to negative 12. So whatever sign this is that. Equals, what's negative 20 plus 36? 16. Now, I don't need to solve, right? Because you're not looking for your x-intercepts. You're looking for your vertex.
Yeah.
So I need to bring that 16 and bring it back to life over there. How do I bring it back over there? Subtract. And I end up getting x plus 6 squared minus 16 equals 5. That's your vertex. Is this kind of bringing it back to life a little bit?
Yeah.
Okay. And so one who can be using it, we would use completing the square, but what are we trying to find? What's easy to find? Vertex. What's the x-coordinate of your vertex? What's that called? Axis symmetry. And remember, your vertex, in case you forgot, is the opposite of what's in the parentheses. So the opposite of h and k. What else? What other words do we use to find the y-coordinate of your vertex? We did it with positive Patricia, and I said, here's a funny way to remember it. Min and max, right? So your minimum value or your maximum value. Also, like your highest or your lowest value.
This is
Opposite of h. So like right here, what would my vertex be for this one? Negative 6, so it's the opposite of what's in the parentheses, but the same as what's right there. And so that would be your vertex. So opposite of h and k. Okay, that's your notes for today. Does that make sense?
Yes.
Okay, so I'm going to explain to you guys, we're going to be breaking into groups. And so I'm going to explain the activities, but I need like your full attention because some of them people are getting confused. And I want to make sure we got it down. So let me pause this video real quick.